today's topic. Ooh, by the way, this entire chapter is about standard form of an equation. Like, so whenever I say, hey, get out the notes for standard form of an equation, if you want to highlight that at the top of your page or color it in some way, standard form of an equation notes. That's what we're going to deal with this entire unit. So dealing with word problems, we're going to try to figure out how we can describe limited word problems using equations. Every time we relate in our portion of our word problem, we're going to make sure we have some sort of rate of change times number of units plus another rate of change times the number of units, and then it's going to equal some sort of total. And because we're dealing with companies today, it's probably going to deal with total cost that it would charge the company. All right, first word problem. Let's just take a moment and read and try to figure out, what if we wanted to define some missing pieces? So within this, one color, let's make it represent the number of pants. So $12 deals with pants. $10 deals with the blouse, which will be in another color. So when we relate, we're going to use this setup, but we're going to try to figure out, like, rate of change of what? Number of what? And then total what? I talked about how the total cost is what we're probably going to be dealing with today. So now, number of pants is going to represent one of those number of units. So the rate of change, instead of that triangle, I'm going to say rate of, well, how much did it charge? So rate of cost per pants. So the number of units, we concentrated on shirts or blouses. So I'm going to put blouse. And the rate is cost per blouse. So $sign per blouse. Your very last color is going to represent this total. Whatever the rate is, meaning the first symbol, that's what your total amount is going to be. So the total amount will be that $100. So I'm going to actually box in my third color the $100. So the rate dollars per pants is 12. And then we're letting X be the number of pants. Then we're going to add on top of that the cost per blouse times the blouse's variable, and that's going to equal $100. We actually have 10 items in a box we've got to care about. So when we solve 12x plus 10y equals 100, we've got to rewrite one of them. And I'm going to tell you, rewrite the second one. Whatever the second one is. That way we can stay organized. But if we know how many number of pairs of pants we have, we know that, well, whatever remains from the 10 is what that should be. So here's how we're going to write it. 12x plus 10, this y is going to be different. Instead of y, we're going to realize that it's going to have to be, well, there's only 10 items in a box. Take away the number of pairs of pants, and that'll leave me with the blouses. Now we're ready to solve. We're going to distribute, so 12x plus distribute, 100 minus 10x. So 2x plus 100 equals 100. You get 2x on the left side and nothing on the right side. So divide both sides by 2. How many pair of pants will fit in this box?
0.
None. So we have how many of each items in a box? No pairs of pants. But we'll have 10 shirts. Or 10 blouses. Still have the company of Stitch Fix. However, we've got 9 items in a box. $12 per pair of pants, $10 per blouse. Customer still says, I want to spend exactly $100. Now, how much can go into this box? So we realize we've got 2 things within this box. One of them is realizing we've got pairs of pants. So I'm going to let X equal the number of pairs of pants. So defining our variables. X is going to be the number of pairs of pants. Y is going to be the number of blouses. That has not changed. So cost of pants times the number of pants plus the cost per blouse times the number of blouses. That's going to equal the total cost that the customer is willing to pay. So we still have $12 per pair of pants. And we still have $10 per blouse. And that's going to be $100. If I know the number of pants, and I know there should be 9 items in a box, then that means the number of blouses is going to be, well, the total number in the box minus the number of pants. So I adjust the number of blouses to show that if there's 9 things in this box, I'm just going to take away the number of pants.
Can we write this in pencil or just...
How many pairs of pants now? So now, if the customer, because I want us to make sense of the problem. If the customer spends exactly $100, they can get five pairs of pants and how many blouses?
4.
Where did you get that?
5 times 12 is 60. 4 times 10 is 40. 70 again.
Oh, so you go back to the very beginning. Okay. How else could we have done it? So Justin made sense of, well, wait a second, 12 times 5 is 60, plus 10 times 4 is 40. That gets you to 100. How else could you have done that? Okay, Dylan.
Realize you already used 5 items. You only have 4 items left.
So looking at the box, we can only have 9 items in a box. So there's 2 ways we can look at this. Dealing with the cost aspect, going back to the top, or realizing, hey, we've got 9 items in a box. If we've already got space for 5, we have space for 4 more blouses. So let's try it again. We're going to do this one more time today, and then we're done. One more time. What? I'm going to let you cruise. You try this problem on your own, because most of you, I like how you're self-starting, you're going with it. Let's talk about what happens. Those of you who already self-started, We've got a difference in prices. So we're still going to let X equal the number of pants. And then when we write the relation, so where we're different. So if we up the charge, let's say we're using silk or a different company to produce the pants or a different company to produce the blouses, so their charges go up. Can we still help this customer? So we've got 15x plus 20y equals 100. We still have, we go back to 10 items in a box. So going back to 10 items in a box. Distribute, like terms. We get negative 5x plus 200 equals 100. Looks like we have negative 5x equals negative 100. Pairs of pants. How many pairs of pants should we have? Should end up with 20. When we have something that's impossible within our restriction, like you can't have past 10 items in a box, we can't help this customer. Sometimes we can't help them. It's without our means, or it's beyond our means.